Now, there is one more issue that could come up in this kind of an experiment that I do need to make sure to talk about. And so if we're going to give, if we have this medicine and we think the medicine might make people less sick, well, what we want to do is set up in the experimental group, they get a pill with the medicine in it, and the control group gets no pill, right? And then we get these results. And suppose we get these results, we make sure that they're statistically significant. So we say this is a real effect. Wow, we had a pretty big impact on this, so our pill must have worked. If we had made that conclusion, it'd sound good, and many experiments were done where they did this kind of thing and made conclusions like this, and they were completely wrong. And the reason is because, remember, a control group has to be exactly the same as the experimental group, except for the one thing that you want to change, the treatment that the experimental group is going to get. And if we look carefully here, the treatment that we wanted the experimental group to get was whether or not they received the medicine, whatever the chemical or compound is that we're giving them. And at first glance, it looks like, okay, this group gets the medicine, this group doesn't get the medicine. That's the only difference. But actually, that's not the only difference. This group gets the medicine in a pill, and this group doesn't get the medicine and doesn't get a pill. That's two differences, pill and medicine, and no pill and no medicine. So why does this matter? Because the knowledge that you're getting some kind of treatment, the knowledge that you're getting a pill by itself may have an effect. So that becomes a very significant potential confounding variable. And that is why in experiments we use these things called placebos. Okay? So the classic example is when we're using a drug, but this could count for any kind of treatment. So placebo is usually thought of as a sugar pill, but it can be any kind of dummy medicine or any kind of dummy treatment. So this would even count in psychology when we're testing like a new form of psychotherapy. The patient simply knowing they're getting some kind of therapy may respond to the treatment all by itself. So that's a confounding variable. This is called the placebo effect. So just to be clear about what this is when participants taking a placebo, getting some kind of treatment, having the knowledge that they're getting treatment, react as though they were receiving real treatment simply because they believe that they are. So the knowledge that you're getting treatment, that something is being done to you, your attitudes about that, your beliefs about that can drastically impact the outcome, the dependent variable, the effects of the study. Now, the important thing to understand about the placebo effect, something I might put on a test question, is this all in your head? We have a general tendency historically to think the placebo effect is just something that someone thinks is happening to them. So for example, if we are asking people how sick they are and we give them a pill and we ask them, do you feel better? They might believe that they feel better even though they're not any less sick, even though no real physiological changes have happened. But as we've studied this placebo effect, it turns out, and this is the key point, the placebo effect is absolutely not just all in your head. In a sense, you have to think about this. What do we mean by all in your head? What's in your head? Well, your brain is in your head. Is your brain totally disconnected from your body? Does your brain have no influence on your body physiologically? Obviously not. Of course, your brain does all kinds of things to control different things about your blood chemistry and heart rate, all kinds of different physiological responses. So it's possible to have a change in attitude, a change in belief, that has a very big impact on your physiology. So the take-home message here is that the placebo effect in multiple studies has been found to be associated with significant, detectable, real chemical, physiological changes in the brain and body. So if I ask you on a test whether the placebo effect is just all in your head, the answer is absolutely not. So if we go back to our experiment, if we want to create a true control group, we don't want to give the one group a pill and the other group no pill. We want to give the one group a pill and the other group a placebo. Now we have this group is getting a pill and medicine, and the other group is getting a pill with no medicine. So now the only difference between the groups is that the one group is getting the medicine and the other group is not.